Concerning Pontchartrain, do you agree that we should not expect the apparent x-axis curvature to match the apparent z-axis curvature?
Only if the Earth is flat and the apparent curvature is just a mirage. As my daughter and I explained, a ball has the same amount of curvature going side to side as it does toward and away from you. We've been over this. A toilet paper roll has no curvature across the x-axis and only has curvature across the z-axis. Or unless you're talking about some kind of oblong pear shape. I think it's kind of odd that you're asking this right after we went over this. But that's okay because it kind of reminds me of another claim that Neil Tyson made.
So one last thing, which should be obvious, if you pay attention and think about it. If you send a ship straight to the horizon, eventually it begins to disappear until it's no longer visible beyond your horizon. And you should ask yourself, what kind of surface would produce that result?
The ocean,
the
ocean has a ramp. It's like a parking lot. The ocean has a ramp.
It's an elevator.
Yeah, it's an elevator. Then you get to a certain point, and they just like going down.
Seafarers knew this. And so, however flat they would have imagined the Earth to be, they couldn't have accepted it to be completely flat, because otherwise you would never not see the ship.
I think it's really interesting that he would say that when he also said this.
You don't see the curvature of the Earth if you are 2 millimeters above this beach ball. You just don't. That stuff is flat.
That was referring to this Red Bull drop photo. You don't see the curvature of the Earth when you're 2 millimeters above this beach ball. That is the equivalence of being this high up. But you can see the curvature of the Earth when you're at ground level? I don't think so. He's kind of biting his own tail there and contradicting himself. Now going back to his illustration here, we can see the sinking boat, and we can also see the sinking sun out in the distance there. Now let's listen to how the world-famous globe Earth astrophysicist Neil deGrasse Tyson explains how the sun appears to set every single day.
So now, so we have the sun moving across the sky. So sunlight was generated in the center of the sun. We did a whole explainer video on how the sunlight gets out of the sun. And then it comes through empty space, all right, gaps that distance in 8 minutes and 20 seconds. Then it moves through our atmosphere, and then it reaches your eyeballs. Okay. The light through the vacuum of space moves at the speed of light. When it goes through Earth's atmosphere, it is no longer moving at the speed of light.
It slows down?
It slows down.
Okay.
Anytime light slows down, coming at an angle into a medium, the path of light bends. The physics term for that is refraction. It refracts, much like a straw. Do people still use straws?
No.
No, yeah, they're paper straws now. I have straw issues at the moment, but I'll get over them. All right, so if you put a straw in a half-filled cup of water, tilted, you'll see the straw bends. The light bent on its way out of the liquid into the air of the straw. So that bending is no different physically from going from vacuum to air. Two different media of different densities. Okay, I say all of this because as the sun approaches the horizon to set, it's actually moving faster than you see it to be. So refraction is taking the sun lower than the actual position on the sky you think the sun is.
Oh, that's, oh man,
it's crazy.
That.
So he's saying when you see the sun set every single day, the light from the sun does not travel in a straight line, okay? It's not parallel. And when you see the sunset every day, you're actually seeing a mirage.
That's really cool.
So what it means is if you had some super missile, okay, and you aimed it at the setting sun, and it could get there instantly, it would just miss it. It would just fly off into space, because that's not where the sun is. That's the image of the sun bent into a direct line for your line of sight.
And I agree with him on that. Although you don't need the vacuum of space in order to make that happen. You just need an atmospheric gradient, which we have. The air is denser down low close to the ground, and it's less dense, thinner, way up high. But hey, just acknowledging that we see a mirage every single day at sunset and sunrise, that's really good common ground to have. It's also worth noting that the title of Neil Tyson's video that I got that from is The Sunset Illusion. You can find that on Star Talk. Those are his direct words. TwirlySocrates, do you agree with Neil Tyson's statement there?
I agree with him. He is saying the sun appears to be higher than it actually is. In other words, that's a superior mirage. Now concerning Pontchartrain, unlike the bottom of the pylons, the curvature at the top of the pylons is not a mirage. We know this because the displacement happens seemingly independent of weather, even when it's overcast or foggy.
The sunset illusion still happens on overcast and foggy days, so I don't really see what the problem is here. And it's not like you've shown me a whole bunch of different pictures to compare either.
Fog. Sun.
Are you telling me the bottom of these pylons is not being obscured by fog?
We are not looking at fog, no. That's just fall off from normal atmosphere.
Atmospheric opacity, its ability to block your view, is fog. And that's not preventing refraction from taking place here.
You can literally see all the way to the horizon. The reduction of visibility is not appreciable.
Then the bottom of the towers would have to literally be missing here.
Why would fog prevent me from seeing the bottom of the tower, but not the top?
It is for the same reason a cloud can prevent you from seeing part of the sun, but not the whole sun.
If you believe that this photo counts as foggy, then I would say that you could apply that label to any weather at all.
Any weather that fits the definition of the word fog that I provided here.
When you look at distant objects, there's always some atmospheric fade out, even in the best weather. But unlike you, I would not call that fog.
Well, suit yourself. I think we're just going to have to call an impasse on that one.
We also know the curvature at the top of the pylons is not a mirage because the displacement happens at the top of the pylons, away from the Earth's surface. All the mirages I have ever seen are very close to the Earth's surface, a few feet above a hot road.
Okay, do you agree that this is not above a hot road, and that this mirage is more than a few feet above the surface? TwirlySocrates has chosen not to answer. Do you agree that mirages don't only happen at low elevations?
Yes, for superior mirages. And no for inferior mirages. The pylon tops can't be a mirage because they're displaced downwards. Inferior mirages don't happen up there.
Please keep in mind, this is a zoomed-in image of the Pontchartrain pylons at a distance. Faraway things on the horizon often look very tiny when you're seeing it in real life. Now this is the famous Skunk Bay time-lapse footage. Please pay attention to how the mountains appear to move up and down throughout the day. This is due to refraction, and I'm pretty sure those mountains are bigger than the pylons. If refraction can cause the mountains to appear to move, do you agree that can also cause the top of the pylons to appear to move?
The mountains are displaced upwards in the morning by a superior mirage. During the day, the image drops closer to reality. It's not an inferior mirage.
During the day, the image drops closer to reality. It's not an inferior mirage. If that were so, the mountains would have to literally be moving up and down. This is at 12 p.m., and those movements appear much more significant and rapid now. You appear to be saying that's how they really are, and in the morning, when they appeared much more steady, that was the illusion. Whatever, I'll put that aside for now. Since the mountains are bigger than the pylons, do you now agree that the height of an object doesn't disqualify it from being miraged? Can we call this a resolution, since your opening statement was the top of the pylons can't be a mirage because they are high up?
No, it isn't, dude. Inferior mirages cannot happen at height. Period. It's not happening to the mountains. It's not happening to the pylons.
Okay, now you appear to be contradicting yourself. The mountains either are experiencing a mirage, or it is impossible for the mountains to be miraged because they are so tall. You can't have it both ways.
I am not aware of any realistic scenario that would have an inferior mirage displacing the tops of the pylons. So no resolution.
At this point, the pylons themselves are irrelevant. This boils down to your claim that something can't be a mirage if it is up and away from the surface of the Earth. This is what I'm trying to resolve, wherein you claim to have never seen a mirage outside of a few feet above the Earth's surface.
No, I didn't say that. I was, and am still talking about inferior mirages at the tops of the pylons.
This is a direct quote of you saying that, and it just says mirages. It doesn't specify certain kinds of mirages.
I have agreed multiple times that a superior mirages happen away from the Earth's surface. If you look at the sun or stars right now, they are displaced slightly upwards. It is a small effect. It is more than common, it is expected.
All the more reason why you should just acknowledge the resolution and form a new opening statement that's hopefully better worded.
Inferior mirages do not just happen anywhere or anytime. You need to heat the air bottom up. This requires sun and proximity to a heat-able surface.
Do you acknowledge that the conditions for an inferior mirage are already present here?
At the bottom.
Yet for some reason you claim they just end there and it's just impossible for those conditions to extend higher. Here's an illustration of an inferior mirage by BYJUS. And here's another one from the University of Wisconsin. Do you agree that the top of a distant tree is capable of being miraged despite it being more than a few feet above the Earth's surface?
If the light moves through a strong enough density gradient, it's possible. A mirage of that size would require extreme conditions.
Okay, so you now agree that the pylons being tall doesn't make it impossible for them to be miraged.
Under extreme conditions, yes.
All right, we can call that a resolution. Now, I understand you've got other arguments you'd like to make about Pontchartrain. We can come back and talk about those in another video. Thank you all for watching, guys. This message has been brought to you by the Flat Earth Institute of Science, with a shout out to our Flat Earth friends at jdecals.com.
And I remember saying, boy, the world is flat. I'm looking it in the eye. I see further, I see wider, I see clearer. I've got to take ownership of myself. And I stood with my heart higher, I stood with my head higher, and I walked forward and started doing things in that way that I was saying earlier, without asking so much permission all the time, and got a lot more done and became a lot more myself and found more satisfaction.
Oh, yeah.